Okay, homework out 4.3. Geez. Scroll up to the top. Maybe. Okay. Okay, so the first 6 are review from what we just did last chapter. You're finding the x-intercepts of the following quadratic equations or functions. So remember, you can do so by factoring, which if you can factor, it's definitely the easiest one, I think. You can use the quadratic formula. Then take the square. All right. So if you can factor, I would go ahead and factor. Number 1 and number 2 are factorable. So that's where you need to think of factors that multiply together to get C, which this one would be negative 10, that add up to B. I'll write it right here. So for factoring, factors of C that add up to B. And remember, this is ax squared plus bx plus c. So C is negative 10, b is 3. So factors that multiply together to get negative 10 and add up to 3. Number 3, I recommend using the quadratic formula. And then the last 3, they give them to you in vertex form. So I'll do number 5. So what you're going to do on 4, 5, and 6 is put them equal to 0. Okay. And then you're solving for x. So the first thing I'm going to do, you're solving for x, the first thing I'm going to do is subtract 9 from both sides. Subtract 9 from both sides, so I get negative 9 equals negative x plus 3. Okay. Then you're not quite ready to take the square root. You have to get rid of this negative. So you're going to divide both sides by negative 1, divide by negative 1, so you get 9 equals 3 squared. All right. Now is when you take the square root of both sides. So you take the square root of 9 and you take the square root of x plus 3 squared. Yes, let me draw it in. Square root, square root. Okay. Square root of 9, you get plus or minus 3 is equal to x plus 3. Let's go over here. Then x plus 3 is equal to positive 3, and x plus 3 is equal to negative 3. Okay, and then you would solve those for x. So you would subtract 3 from both sides. So on this one, you would get x equals 0 and negative 6. All right, so that's number 5. So you're going to do the same things for numbers 4 and for number 6. Moving on. So this has to do with what we were talking about in class today. I started doing, I need to put myself there. I need to move myself somewhere. Okay. So number 7, they want you to write a piecewise equation and they give you a table. Here is, okay, you could graph it. You could graph it, and then once you see your graph, you'd be able to write your piecewise. Because if you graph it, you're going to get an absolute value function, so then you'd be able to write the equation of this and the equation of this. But you don't need to. What I recommend doing is finding the vertex. So find the vertex. And remember, for absolute values, the vertex is where it's symmetrical, so it's where the line of symmetry is, and it's where it changes direction. for instance, I'm just going to look at number 8. Here's the vertex. It's at -5, -4. Okay, that's the line of symmetry. So once you find the vertex, you can use that point to write your point slope equation. And then you just have to find the slope of both lines. So this is the vertex. Sorry, I got distracted. Is -5, -4. And then you're going to have the same points on either side. So -3, -4, -5, -3. So you're going to have the same y values on both sides, -3 and -3. And then, sorry, not -3, -6. No, -3. I'm right. -3, -3, and -3. So the y values are the same. -2, -2, -1, -1, 0, 0, and so on and so forth. So where does that happen on your table? It's very similar to finding the vertex for a parabola. Okay. So your vertex is 2, 0. So you have the same y values on either side because that's where it's symmetrical. So I have 3, 3, and then 6, 6, and then this would be 9, 9, and so on. Oh, so my vertex is 2, 0, 0. And now I have a, really I could write my absolute value equation once I figure out the slope. So what is the slope? So the slope, because you're going to have two different slopes, right? They're going to be opposite of each other. So the first one, what's the slope of this? That's your first line. What's the slope of that? -3. It's going down by 3 each time. So if I were to write this as an absolute value equation, I could write this. F of x equal to my slope, which is 3. Okay, when you break it up into piecewise, you'll write positive and -3. Oops, I need something to do the absolute value. Just draw a line. Oop. Come on, work with me, work with me. Oh my gosh, computer. Thank you. 3 times the absolute value. Then in here we have x, your vertex is 2, so it's x minus 2, and then I'll just draw the line. There. Absolute value of x minus 2, and then 0. So we didn't shift any up or down. So if you want, you can write plus 0. So that's the absolute value equation. So the piecewise, your first one would be -3, x minus 2. And if you want to write the plus 0 in, you can. If not, you can leave it out. So that's your first one. And your second one is 3 x minus 2. So remember, you're just taking you take the absolute value equation and just make the slope negative for one of them. So they're exactly the same, except the slope is negative on the first one, or on one of them. So for this one, the domain, when is the slope -3? When is the slope -3? It's -3 until you hit 2, until you hit your vertex, and then it becomes positive. Okay, so you can just write This is true when x is less than or equal to 2. Let me draw in my sign. There it is. Oh, there. So I'll graph this one in a second so we can see it. Okay. So this is the equation, and it's when x is less than or equal to 2. And remember, you could write you don't have to write your equal sign here. You could write it on this one. So then this one is true for x is greater than 2. You can write the equal sign on either one, it doesn't matter. So those are your two piecewises, or that's your piecewise function. Those are your two functions of your piecewise. Oh, let me see if I can graph it real quick. Do I have Desmos up? Of course not. Let's get rid of this. Okay, so we have, actually I can put it in a table, I think. Can I put it in a table? I think I can. Yeah. That way I can prove it to you. So I'll put it in the table. -1, 9, oop. 1, 0, 1, 2, 3, 4. And then on this side we had 6, 3, 0, 3, 6. Okay. Oh, that's annoying. We'll put in one more point so it's 5, 9. There we go. They should be connected. I wonder how I'd make them connected on here. They should all be connected. It's continuous. Okay. So there, that's what happens if I put in the points. Oh, because it doesn't know. It doesn't know they're supposed to be connected. I don't know how to tell it to do that. So these should all be connected. But that's our graph. So our slope is -3 until we hit 2, and then it switches to being +3. So that's our turnaround point. So -3 slope, +3 slope. So that's explaining our domain. So if we are less than 2, it's going to be -3. If we're greater than 2, it's going to be +3. Okay, let me go back to it. So that's number 7. Number 8. Let me get rid of my, oh, actually, I'll leave that. Whatever. They give you the graph. Let me change colors. We'll make it, I don't know. Hey. Why can't I change my color? Huh, okay, I guess we'll stay blue. So 8. So they give you a graph, and I already told you what the vertex is. So identify the vertex, which is -5, -4. So you know that. The only other thing you need to know is the slope. So what's the slope? There's my color option. Oh no, it's too green. So what's my slope? You could pick 2 points and figure it out that way, or you can go, okay, we're going down 1 over 1, down 1 over 1. Okay, so over here, it'll be the opposite, so we'll go up 1 over 1, up 1 over 1. Okay, so our slope is 1. When you're writing the absolute value equation, you use the positive slope. It's when you break it up into piecewise that you use the -1. Okay, when we wrote our equation over here, we used the positive slope. So let me delete whatever that is. Oh, yes, I'm sure. Really wish I could change the color. It's really annoying. Okay. So Okay. You're going to have it. It doesn't tell you us, so I'll make it f of x. F of x equals my slope, which is 1. And then you have the absolute value. Oops, got away from me. The absolute value enough of, oh, sorry. We'll get there. I'll figure it out. There. The absolute value of x. And then it's minus 5, so in here it becomes plus 5. It's the opposite. We can use that for absolute value. No, it looks too much like a 1. Okay, there. So the absolute value of x plus 5, and then you go down 4, so minus 4. So that is your equation. You do not need to write the 1. You do not need to write the 1, but that's your equation. All right, number 9. I'm just going to go through all of these because they're kind of hard. So obviously try them by yourself first. Make a table of values. Be sure to include the vertex in the table. So what I would recommend starting out with on this one, make a table of values. Okay, I would start with the vertex. Go ahead and pull out the vertex. So the vertex is 6, here, 6, negative 8. That's your vertex. 6 and negative 8. All right, go ahead and just fill in your x values. Let's see what I leave room for. We'll do probably just 4, 5, 6. 4, yeah. 5, 6. X values, we're just going up by 1. 7, oops. 7, 8. Good enough. 4, 5, 6, 7, 8. Those are my x values. So now your slope is 5. If you want, you can substitute in values of x and solve it. But here, your slope is 5. So remember, before you hit your vertex, you're going to be going in it. You're going to have a negative slope. You're going to have a negative slope. This is negative 3. Oh, yeah, that's fine. Negative 3. And then this one is negative 3 plus 5 is 2. Hopefully. Yes. Okay, all I did was use the slope. The slope is 5. Okay, so this is going to have a slope of negative 5, and then we're going to hit the vertex, and it's going to switch. And now we're going to have a slope of positive 5. So negative 3, and then negative 3 plus 5 is 2. All right. Hold on 1 second. Let me pause you. I want to try something. Okay. You could also substitute in and solve. For instance, if I'm going to substitute in 2 for x and solve, h of 2 equals 5. I'm getting lazy. We will just do CI. The absolute value of 2. It just looks so bad. Absolute value of 2 minus 6. There. And then minus 8. So that becomes, we'll 5 times the absolute value (2 minus 6) Oh, I meant to do 4. Sorry, we don't have 2 in our table. My bad. 4. Sorry, because we have that in our table. So the absolute value of 4 minus 6, that's -2, absolute value sign. And then -8. Okay, here's where you have to think about the absolute value. I messed up the first time I did this. The absolute value of -2 is 2. So this turns into 5 times 2. The absolute value of -2 is 2. And then -8. So you get 10 minus 8, which equals 2. 4 and 2. It's a little bit more work. So I think it's easier if you just use the slope and realize that until it hits your vertex, it's going to have a negative slope. Once it hits your vertex, then it turns into a positive slope. So slope is -5, -5, and then it changes to +5. Okay. Number 10. Well, this is going to be hard to do on here. Maybe I'll just walk you through it. So number 10. You're supposed to graph. Okay, so same thing. I would pull out your vertex. What is your vertex? It's 6, 4. The opposite of what you see inside, so +6, and then 4. So I would graph your vertex. And then, oh, it's actually not so bad. This is your slope. Remember, this is your slope. So you're going to graph your vertex, and then your slope is 2/3. So up 2 over 3, up 2 over 3, up 2 over 3. Okay, that's this side. This side, which will be over here. Okay, let me zoom in. So 6, 4. 1, 2, 3. Oh, wait, no. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay. There we are. There's our vertex. So then your slope is going to go on this side. It's going to go up 2 over 3, up 2 over 3. Over here, because when it's less than 6, so when x is less than 6, it's going to be -2/3. Okay? So you're going to end up looking, it's going to be an absolute value graph. There's no good way for me to graph it. I guess I can graph it on Desmo so you can see what it looks like. Okay, let's do that. Let's get rid of that guy. So we're going to do, I already forgot what it was. Hold on. We'll do both of them separately. So the first one is -2/3 x minus 6 plus 4. We're going to have to zoom out. Okay, that's one of them. Let's see. Oh, that's because I don't have the other one in here. And then the other one is 2/3 x minus 6. Oh, that makes it confusing. I mean, yeah, let me just write it as an absolute value equation. My bad. So it's going to be 2/3. Then, where is it? We have the absolute value of x minus 6 plus 4. There we go. Jeez Louise. Oh, now we have to zoom in. There. So your vertex is at 6, 4. Okay. And you see how this side has a negative slope. So really, when you go to graph it, you can go, okay, 2/3. So up 2 over 3, up 2 over 3, up 2 over 3. Over here, we're up 2, we're over 3, we're up 2, we're over 3. So you're just going up 2 over 3. All right. I'm gonna minimize that. Okay, so that's how you would graph number 10. Okay, and then these guys, interpreting, oh, I moved myself, interpreting absolute value. So evaluate each expression for the given value. So instead of saying negative s, think of this as the opposite of s. So what is the opposite? So s equals 4. So what's the opposite of 4? Negative 4. Okay. So now we want to evaluate for negative t. So the opposite of t. What's the opposite of t? T is negative 7, so the opposite is 7. Okay. So that's kind of covers the first 4. Let's see what else we have. All right. So you have the absolute value of v. So v is negative 25. What's the absolute value of negative 25? So how far is negative 25 away from 0? 25. I'm not worried about that one. Okay, they start to get a little crazy with their negative signs. Where do I want to look? Okay, 19. No, sure. So 19. You have the absolute value of the opposite of negative q. Oh, and q equals 8. So I'm really tired of drawing in absolute values. Let's use a line. Okay. So the absolute value. Before you even substitute an 8, I would go, okay, negative and a negative. That's already a positive q. So this becomes the absolute value of q. Let me grab my little line. Okay, a negative times a negative. The opposite of a negative is a positive. The opposite of a negative is a positive. So q, and then q equals 8, so you're taking the absolute value of 8, which is just 8. So that's the answer for that one is 8. Let me try 20. So once again, go ahead and just simplify it out. I'm going to simplify what's inside first. I'm going to do that. So the opposite of negative r. Okay. So I'm just going to simplify those. So I have negative and then the absolute value. The opposite of negative r is just r. Okay, now is when you have to substitute in negative 9. So that is equal to the negative, okay. Then we're going to substitute in negative 9. Absolute value. So what is the absolute value of negative 9? The absolute value of negative 9, how far away is negative 9 from 0? Distance can't be negative, so it's 9. But you have a negative on the outside, so the answer is negative 9. Okay, don't forget about the negative on the outside. Okay, I think I'll leave you there. Yes, I will. All right. Good luck. Wait for it. Good luck.